Black holes, man, just the name, it kind of sends a shiver down your spine. These cosmic monsters, these like vacuum cleaners of the universe, just gobbling everything up. But what would happen if you were the one getting sucked in? Like, what would it be like to fall into a black hole? That's what we're diving deep into today.
Yeah, I mean, SciFutura really paints a picture of this, like, ultimate demise.
Mm.
It's not like taking a wrong turn and ending up in, I don't know, Cleveland. It's a one-way trip, and
Mhm.
there's some crazy physics involved.
Right. Exactly. So, first things first, we got to understand, like, what are these things?
Absolutely, yeah.
So, imagine a star way bigger than our sun, like at least 3 times bigger, and it dies. Goes out with a bang, a supernova, but the core of that star, it keeps collapsing in on itself.
You're talking about squeezing, like, the mass of several suns into a space smaller than, I don't know, Chicago.
Yeah, it's wild to think about. And that's what a black hole is. Not empty space, right? It's like super dense.
Yeah.
And the gravity there just gone nuts.
Totally. And that density, that's the key. SciFutura is really clear about that. The gravity's so strong, nothing can escape, not even light. That's why they're black. No light bouncing back for us to see.
It's like hard to even picture.
It is, yeah.
But they are out there, right? Like lurking in the universe.
Oh, yeah. They're out there. We can't see them directly, but we can see how they affect things around them, like stars orbiting weirdly or gas getting superheated and giving off X-rays.
It's kind of freaky, but also like super cool.
Oh, definitely. And there's even a supermassive black hole, Sagittarius A, right smack in the middle of our own Milky Way galaxy.
No way, really?
Yeah, but don't worry, it's like 165 quadrillion miles away. We're safe for now.
Oh, okay, good. Good to know. But that's huge, though. A supermassive black hole just hanging out in our galaxy. It makes you think, like, what role do these things play in, well, everything?
Right. See, Futura touches on that. They're not just these, like, random oddities. They're part of the fabric of the universe, influencing how galaxies form and evolve.
It's all connected, man.
Yeah, totally.
Okay, so let's say, hypothetically, you were heading towards a black hole. What happens as you get closer?
Well, there's this thing called the event horizon.
The point of no return, right?
Exactly. Cross that line and you're not coming back. Gravity's got you. But what happens next? Well, it depends on the black hole, like how big it is. That's something I found really interesting in the SciFuture article.
Yeah, I remember that. It was like different sizes, different fates.
Right. Smaller black holes, what we call stellar mass black holes, they have a really intense gravitational field near their event horizon.
So, like, if you were falling in feet first,
Your feet would feel way more pull than your head.
that's, not good.
Not good at all.
What happens then? You just get, like, stretched out.
Basically, yeah. They call it spaghettification. SciFutura actually uses that term.
Spaghettification. Wow.
It's kind of gruesome, but that's the reality. The difference in gravity between your head and your feet gets so strong, it just stretches you out.
Ouch. Okay, so small black holes equal spaghettification. What about the big ones, like the supermassive black hole?
Ah, yeah. Those are different. Their event horizons are so vast, the gravity is more evenly spread out at the edge.
So you wouldn't get, like, instant spaghetti.
Probably not. You might not even feel it when you cross the event horizon. It would just be like falling.
Really? Huh. So a gentler demise, at least at the start.
Well, gentle might be pushing it. You're still falling into a black hole. You're still going to get pulled towards the singularity at the center.
Singularity.
Yeah, that's like the infinitely dense heart of the black hole. Get pulled in there, and, well, that's it. You're crushed. Out of existence.
So no matter what size black hole, it's a one-way trip.
Pretty much. Yeah.
Okay, but there's another wrinkle to this whole thing that SciFutura brought up, time.
Ah, yes. Time dilation. It's one of the weirdest things about black holes. You see, gravity, it doesn't just pull on matter. It messes with time, too. The stronger the gravity, the slower time moves.
Wait, so, like, if I'm falling into a black hole, time slows down for me.
For you, time would feel normal. But for someone watching from a distance, you'd seem to slow down as you got closer to the event horizon.
Whoa, really?
Yeah. And eventually, you just seem to freeze, stuck at the edge of the black hole, your image getting dimmer and redder.
That's so bizarre.
It is. It's like the universe is playing a trick on you. To the person falling in, time's ticking away normally. But to everyone else, they're frozen in time, right at the edge of oblivion.
It's like a cosmic cliffhanger. The story never ends. Well, it ends for the person falling in, I guess. But for everyone else, it's just this frozen moment.
Exactly. It really shows you how relative time is. It all depends on your perspective. And around a black hole, those perspectives get really messed up.
Okay, so falling into a black hole is definitely not on my to-do list. But even with all we know or think we know about black holes, there are still some pretty wild theories out there.
Oh yeah, SciFutura got into some of those, like Hawking radiation.
Shocking radiation.
It's this idea that black holes aren't actually totally black. They leak a tiny bit of radiation over time.
So they're not like eternal.
Well, the process takes a really, really long time, like longer than the current age of the universe. So practically speaking, yeah, they're pretty eternal.
Still, it's kind of mind-blowing to think that these things, that these seemingly inescapable objects, could eventually just evaporate.
It is, yeah. And then there's the really out there stuff, like what if black holes are doorways?
Doorways.
To where? That's the big question, right?
Yeah.
Some theories say they could lead to other universes, or maybe other parts of our own universe.
So instead of getting crushed, you could end up somewhere else.
It's possible,
Yeah.
but it's highly speculative, and honestly, it'd be a pretty risky trip.
Yeah, no kidding. I mean, the SciFutura put it pretty bluntly. Would you risk a cosmic shortcut if it meant you might get instantly annihilated?
It's a tough call. On the one hand, you have the unknown, the possibility of discovering something incredible, but on the other hand, you have, well, certain death.
It really makes you think about the balance between curiosity and self-preservation, doesn't it?
It does.
Okay, so let's sum up our little journey into the heart of darkness. Small black hole, probably getting spaghettified, big black hole. You might avoid that, but you're still getting crushed at the singularity. And no matter what, to everyone else, you're frozen in time at the event horizon.
It's a pretty good summary, yeah.
Yeah.
It's a wild ride no matter how you slice it, and SciFutura really captured that.
It makes you wonder, like, what else is out there that we don't understand? What other crazy stuff is happening in the universe where the rules of physics as we know them just don't apply? It's both terrifying and exciting, isn't it?
Yeah, it is. That's the beauty of it, I guess. The universe is full of mysteries, and we're just starting to scratch the surface. Who knows what we'll discover next?
That's right. And hey, maybe one day we'll even figure out what happens inside a black hole. Though, personally, I'm fine with leaving that one to the theorists.
Yeah, I think I'm with you on that. Some mysteries are better left unsolved, at least for now.
Absolutely. But hey, that's a conversation for another day, right?
You got it.
Until then, keep looking up. Who knows what you might see?
And keep wondering. That's what it's all about.